The auto type is actually a new feature in C++, but I'm covering it here because it's quickly becoming very common. So we're going to start by making a copy of working.cpp, and we'll paste that into our working project and open it up here. And I'm going to add another include header here. This one's called type info, and you'll see what that's for in a moment. And we're going to define a simple function. We're going to define a variable, and we're going to give it a type of auto. Auto x equals func like that. And then we're going to display what's returned by that. And this will all make sense in a moment. And we're going to also look at the type. We're going to inspect the type with type ID. The type ID is actually an operator that returns a type info object. And that type info object has a method called name. And that'll tell us the name that the compiler uses internally for this type. So it's not going to necessarily be the name that you're used to seeing for it. And it's also not necessarily going to be the same name on your system as what you see on my system, but it should give us a good idea of what's going on here. So I'm just going to save this and run it. And you'll notice that we get two things. We get a 42 because our function returned 42. So our variable got the value of 42 and we're displaying 42 here. And type ID tells us what type this variable is. And it says it's I, which is integer. So what the auto type does is it declares an object of a type and it determines that type by how you initialize it. Now, the object is still strongly typed. That X is now an int, and I can't use it as a string or use it as a float or use it as something else. It's always going to be an int. What happened here is really exactly the same as if I had typed int like this. And if I save this and run it, you'll see we get exactly the same result. On the other hand, by using auto, I can change this function and I can have it return a string, which is an STL object, right? And I'll just give it something to return there. And I don't need to change anything down here. I just save this and run it. And now we have a string, and you'll notice that the type ID returned capital S, lowercase s. It may be something else on your system, but it's a different type. And that type is now a string. So this auto is now exactly the same as if I had typed string here. And if I save that and run it, you'll see we get exactly the same result. All auto does is it allows you to declare a variable when you don't know the type that you need it to be, but however you initialize it will determine that type. Now, this is just a demonstration of what it is and how it works. This is not how you're actually going to use it, but I'm going to give you an example here of how you may actually use this. So I'm just going to delete these things, and I'm going to delete our little function, and I'm going to change type info to vector, and we're going to use an STL object called a vector. And again, you'll learn about these later in our chapter on the STL, but I want to show you an application for this. We're actually going to see auto types really used. So we're going to declare a vector, and it's going to be a vector of ints. A vector is very similar to an array, only different and more powerful. And we're going to call it I, and we're just going to give it 5 members here. And I'll put an equal sign there. It's not actually required, but I like it. It makes it clear. And now I'm going to iterate through this vector with a for loop. And here's where this gets exciting. I'm going to declare an iterator. We'll call the iterator IT, and we'll assign it to i.begin. And this will be while the iterator is not equals to i.end, and we'll increment the iterator. I'm just going to maximize this while I type so you can see the whole thing. So what we have here is this iterator, and you see that's a lot of typing and it's prone to error and it's ugly. And the rest of this isn't so bad. So we'll bring this back down and we will compile it and run it. And there's the result that we get. And so we're basically iterating through this vector of all 5 of these values, and 1, 2, 3, 4, 5, they're each on a line exactly as we expect. Now, instead of all of this, when you're dealing with the STL and when you're dealing with templates, this is not a worst case example. These can get a lot worse than that. I can just type auto, And now it's really clean and really clear, and it's obvious what it is that I'm doing, right? Because if I know the STL, I know that begin and end and container objects always return an iterator. And so here I have an iterator, and I know that it's type vector into iterator because that's what this returns. So I can just save this and run it, and I get exactly the same result. So this is actually, I think, more clear, it's more readable, and it's a lot less prone to error in both typing and in reading. So this auto feature is a real improvement, but it's not without its dangers. Be careful. Only use auto types where the implications are clear and the usage is concise. Otherwise, you could potentially sacrifice readability and even introduce errors that could be hard to find. So let's go ahead and delete our working.cpp, and we'll run clean to prepare for the next lesson.